Good day, everybody. I have a problem that's similar to a Philippine Math Olympiad qualifying competition. I think they used base pi or transcendental base. Okay, but this problem, I just changed the bases and changed the initial conditions slightly. Okay, now let's start out by just simplifying the expression that we're given a function. You can rewrite this as 7 to the 2x plus 1. And you can see this is being accomplished by just multiplying by 7 to the x top and bottom, which is equivalent to multiplying by 1. Okay, so, and then you would have 7 to the 2x minus 1, okay? And this is functionally equivalent. This would be just an equivalent fraction. There may be a larger numerator, denominator. But anyway, what we did is we multiplied top and bottom by 7 to the x over 7 to the x. Okay, which is just a glorified name for 1, since 7 to the x is always positive. Okay, so you see that's what we do. We multiply this object by this, and we got this, which is just easier to work with. So let's carry on. Now we're given this initial condition that f at c, there is a real number, which I can't really prove that. I guess it's true, such that this is equal to 5. And it's actually just assuming that that's true. So that logically you could work this, even if it wasn't true, I suppose. But we're given a real number c such that f at c is equal to 5. We're supposed to evaluate or calculate f at 5c. Okay, now, of course, just as I showed you, we have f of x is equal to this easier to work with expression. And we can calculate f at 2c rather easily here. Now, the reason why we're doing that will become sort of evident. I know this isn't sufficiently motivated, but we know that f of x is equal to this. And so f at c, and that's very well motivated. We know what f of c is, right? And so that's where all of this comes from, okay? F at c is just equal to 5. That's where this 5 comes from. Now from here, we get, when you do some multiplying and collecting like terms, we get this statement right here. And so this would reduce to 3/2. If you divide by 4, is equal to 7 raised to the 2c, right? Like that, right? Now, why is that important? Because the object we're looking at to evaluate, f at 5c, is equal to exactly this. Okay, but by laws of exponents, we get this. Okay, so it's very simple substitution at this point. We just put 3/2 in right here, and what do we end up with? This would be 3 to the 5th is 243, right? 243 over 32, so you would have 243 over 32 plus 1. And then downstairs, very similarly, you would have 243 over 32 minus 1. Now, if you multiply through by 32, I'll do both of these steps. What is that? 32, you would have 275. Okay, now I'm going to cancel the 32s also. Or no, just multiply top and bottom by 32 and you'll get this 275 over 211, right? Again, I left out a slight bit of the arithmetic, but if you multiply this by 32, this is cool. This is cool. It's all good. Not too much work was done in the head here. Okay, because 32 plus 43 is 75. Then right here you get that, but when you subtract 1, the 32 from 43, you would get 211 here. So this is our answer. All right. Now again, folks, this is what, as I understand it, this was a problem from the Math Olympiad qualifying exam in the Philippines back in 2011. Now, I believe that theirs was like pi raised to the x, etc. And I won't. Okay, pi raised to the x, blah blah blah. And the initial condition was maybe f at c is equal to 2. Calculate f at 2c. Here I just switched it to a good old-fashioned integer base, and then went with it. And you'll notice, folks, this sort of has the hyperbolic function structure to it, except I'm just using a plain old integer base right here. And I think this might be like the cotangent, similar to the cotangent hyperbolic function, I believe. But even I didn't have to know any of that or even appeal to any of that to work it out. It was relatively straightforward in my opinion. Once you see a real live number in there, it's something other than pi or e as a base. This step here perhaps is a little suspicious, but anytime you can get rid of some of the variables and turn it to a simple constant like 1, that's usually a good idea. And the rest of it, this is just using the initial conditions. This is the initial condition, f at c is equal to 5. We write down what we mean by f at 5c, which is what we're looking for, and then we can get it in terms of this known constant. This step here was probably the hardest step in the problem for me. You have to multiply through by this, and when you do that, I left out a little bit of the work, but this is what you get. 3/2 is equal to 7 raised to the 2c. And after that, it's fairly straightforward arithmetic, okay? But 275 over 211 is the answer I got. Thanks for viewing.